Hi, grade 12 learners. Today we're going to be doing physical sciences, projectile. We're going to be doing some of the questions which it can help you guys to improve on science on projectile. I saw that many lot of students in grade 12 they're struggling to solve to solve a vertical projectile, which is too bad. So I will be here to help you guys on how to solve such a kind of problems. So we're gonna be doing some questions which is gonna help you guys to know how to calculate some of the things which are difficult to you to calculate. So let us read a statement. Question 3. So guys, before we go more further, I would suggest you to read a question twice or third, because if you read once, you won't understand what is going on. You have to read twice in order to understand what you are writing. So question 3. A ball is thrown vertically upwards from the top of the building of the height 25 meters with a velocity of 12 meters per second. On its way down, the ball passes a door which has a height of 1.9 meters and then strikes the ground. As shown in the diagram below, ignore the effects of friction. So I repeat again, a ball is thrown vertical upwards. So if you can see, the ball is thrown vertical upwards as the statement it says. So from the top of the building of the height of 25. So we have they have given us a height of the building, which is not bad, which is good. Sometimes some questions they don't give us height. We have to find the height. We have to calculate the height in order to find height. So with a velocity of 12 meters per second, so they're giving us an initial velocity which is 12 meters per second. So on its way down, the ball passes a door which has a height of 1.9 meters and it then strikes the ground. Okay, as shown in the diagram below, ignore the effect of air friction. Okay guys, now we are going to the questions. We are going to the questions. So we're gonna jump 3.1. It's a definition. You guys knows about definition, so we're not gonna waste our time defining this term. So we're gonna be doing 3.2. 3.2. So it says calculate the time taken for the ball to reach the maximum height. So they ask us to calculate time. So before we calculate time, let me just draw this diagram for you to make it easier for you guys to understand. So we have this called height, 25 meters to maybe down here, and this. So this is the height. This is the building they're talking about. So it's like this. So here there is a ball which they're talking about, which is pointing upwards as vertically upwards. So here is the ground. So the ball is projected upwards, né? So then for a little while it goes down to the ground and falls down to the ground as it is. So we have a door. And they gave us a height of the door which is 1.9 meters from the top of the door to the down. So we have the height of the door. So we have initial velocity of 12 meters per second. So remember guys, they gave us initial velocity from down here. So if we go upwards, if the ball goes upwards, it reaches the maximum height, which it makes the velocity become 0. So remember, just think, initial is 12. So when it goes upwards, it's going to be 11, 10, 9, 8, 6, and 2 to the 0. So when it goes downwards, it counts. It's going to be 1, 2, 3, 4, 5, and 2 to the 12. until to the 12th. I hope you understand this. So guys, they didn't give us a final velocity. They didn't give us any final velocity. You just saw it yourself in the statement. They didn't give us final velocity.
Hi learners, my name is Bruce and thank you for watching all my videos, and I believe that you will be successful in mathematics. And please don't forget to do the following: like the video, comment in the section, share the videos, and don't forget to press the subscribe button. And may God bless you.
But surely they give us final velocity from the maximum height, which is 0, like I said. So the question says, calculate the time for the ball to reach the maximum height. So where is the maximum height? So the maximum height is here. Here is the maximum height. Maximum height. So this is a maximum height. Sorry. So the question is looking for that time. So we're gonna be saying 3.2.1. We're gonna be writing time. This is what we are looking for. So guys, there are 3 formulas that we have to be looking for. We're gonna choose between those. We're gonna choose one of the formula on all those 3 formulas. So number 1 is final velocity squared is equals to initial velocity squared plus initial velocity squared net. So and 2a change in this distance, change in height. Some people they say change in displacement. So for here I'm gonna choose change in distance for height. So the other formula is final velocity is equals to initial velocity plus 2 plus a change in time. So the third formula, the last formula is gonna be change in distance, height. So it's gonna be velocity, initial velocity change in time plus 1/2 change a change in time squared. So we have 3 formulas that we know for projectile, for vertical projectile, that we can use to find any different answer. So here we're gonna be using the formula of the second formula, which we have initial velocity and we also have final velocity, and we don't have time. So which is here they gave us initial velocity, but they didn't give us the maximum height, but they gave us, we know the final velocity, which I spoke about, which when the ball goes upwards is gonna be decreasing. It's gonna be decreasing until to 0. So this is a final velocity. So we're gonna be saying that final velocity is gonna be equals to initial velocity plus acceleration change in time. So guys, before you go to your conclusion, many lot of students, as I've experienced, when they go to complete their they just forget to point the direction. So guys, it is very important to choose direction. Or are you gonna be choosing down as positive or upwards as positive? It's important to give direction, because if you don't give any direction, your answer will be wrong. So I'm gonna be choosing here upwards as what? As positive. As upwards as positive. So guys, initial final velocity is 0, and initial velocity is 12. So guys, if you choose the direction, either initial velocity is gonna be changing sign or acceleration is gonna be changing sign. So as positive, I'm gonna change sign as in acceleration. It's gonna be negative. If I choose downwards as positive, I'm gonna be changing sign in the initial velocity. So I choose upwards as positive. So it's gonna be a brackets negative 9.8 as constant 9.8. So a change in time. I hope you understand. So if we take this initial to the other side, it's gonna be changing sign. It's gonna be negative 12 equals to, so here plus times minus is gonna be what? Negative 9.8 change in time. So guys, many lot of students, they often lose marks because they divide their numbers from here, and they just do not know every statement has a mark. So guys, do not divide the number from here. First, rewrite this number again for division. So I'm gonna be negative 12 is gonna be negative 9.8 change in time, right? So divided by negative 9.8, and other side we also divide with negative 9.8. See? So we're gonna be canceling now. I'm gonna cancel because they're like them, they're the same. So if we put this statement on our calculator in order to find change in time, we're gonna be finding what? So let us put this answer on our calculator. So it's gonna be negative 12 divided by negative 9.8, which is gonna be giving us what? 1.22 seconds. So we found out our time is 1.2 from the maximum height. Is 1.2 seconds. Guys, do not forget to put units. Without units, your answer is gonna be wrong, and you will be how. But I just wrote this answer, correct answer, but you forgot to put units. So we're gonna be moving to the next question. So 3.2.2 says calculate the velocity with which the ball strikes the ground. So guys, here they are looking for the final velocity, which is from here. Like I said, they didn't give us final velocity, so we are looking for it. So it's going to be 3.2.2. So guys, the formula that we're going to be using here to find the final velocity is this one. It's the statement number one. It's the formula number one, because we have final velocity and we also have initial velocity, and we have a displacement, we have time, we have height, which is 25 might to the ground. So guys, you can't use this second formula because you have a final velocity, and thinking that I also have time, therefore I can find final velocity. No, remember, this formula that we use from here, it is from the maximum height. So we are looking for the final velocity, which is from here. So this is not needed in this statement, so we need this one. So it's going to be final velocity squared is equals to initial velocity plus 2a change in height. So guys, they didn't give us final velocity, but they gave us what? Initial velocity, which is 12. Remember, like I said to the previous, if you want to find your right answer, you must choose a direction. So therefore, I'm going to be choosing downwards as positive. I have some reason for that, because if I choose upwards as positive, it's going to be affecting my answer. Because if you know in maths, if you have, for example, square x squared is equals to, maybe, for example, it's 4. When maybe it's negative 4. If you square root this one, and cancel, and there's going to be x. If you put your answer on your calculator, it's going to give you error. It's going to be giving you error. So guys, I cannot choose upwards as positive, because I know in the end of my answer it's going to be giving me error, which is wrong. So I choose upwards as positive, because if I choose negative from here, as I put negative from here, if I put this calculator, it's going to be giving me the positive answer. So plus 2, 9.8, changes height. Oh, sorry, they gave us height, which is 2, 5, which is 25. So final velocity squared, if we put this statement on our calculator, it's going to be giving us what? Brackets 112 squared plus 2, 9.8 5 is giving us 634. Yeah, it's 634. So we are not done. This is not our final answer because we have squared. We have to get root of the squared. How can we get root of the squared? We have to brackets both sides. So not brackets, we have to put square root in order to cancel we have to root the roots in order to cancel the square root. So final velocity squared and square root both sides. The other side is gonna be square root 8. So it's gonna be 634. So if I cancel this, it's gonna be fine. It's gonna be left with final velocity. If I put that one on the calculator, it's gonna be 634, which is giving us 25,18 because I round into 2 decimal. So meter per second. It's very important to write units. So guys, we're done with 3.2.2. So we're gonna be going to the next other question. So the third question, 3.2.3, it says calculate the time it takes the ball to move from the top of the door to the ground. Okay. So here we want the time from here, from the top until to the ground. So they give us height, but they didn't give us the velocity from here. But we have final velocity. How can we calculate this one? Many lot of students they can skip this one and go to the next the next other questions. So guys, it is wrong to skip a question because it will be in handy in the next question because they will be looking for the answer of the question that you have skipped, and there is no other choice. You have to go back to that question that you skip and try your best there. So guys, we are looking for time. We are looking for time. So remember, in the top we have initial velocity, which is 12. This is our start. This is our starting point. This is our starting point, and this is the end. So this is the end. So remember, in order to find this time, let's just first to find a distance from this start until from here. I hope you understand. Let's just find the distance from here until here. We are looking for the height. We are looking for the height. Let's just say displacement. We are looking for the displacement. Why are we looking for displacement? According to the theory of what people said, they said on the distance and displacement are not the same. Many lot of students they just think that distance and the displacement are the same thing. Guys, they are not the same thing. So distance we are talking about. So distance is like from your home going to school. You're gonna take a long way. They just say your school is somewhere from here. This is your school, and this is your home. You have to travel so far to reach your school. So this is, we call it a distance. So a displacement is when we go straight to the school. This, we call it a displacement. This is a displacement and this is a distance. You see? So distance and displacement are not the same thing. They are different. So this is a displacement and this is a distance. So here we're going to be using displacement because we're going to be starting here to go downwards straight. We are not going to go upwards a long way and we're going to go downwards. No, we don't care about this one. Just don't care about that one. Only that we care is this one. So let us go back to equation. So we're looking for displacement. So we have a height they already given us from the door, and we have a full building which is 25. So I hope you guys understand. So we're gonna be saying like displacement plus change in time height is equals to height, total height. It's equals to total height. It's equals to total height. I hope you guys understand this. It's very important. So displacement, we don't have displacement, but we have a door which is 1.9, and we have total which is 25 meters, Guys, in order to find our answer of displacement, as always, we have to take the number from here to the other side. So our displacement from here is going to be 25 meters minus, because here it's positive, it's going to be minus 1.9 meters. So if we put our calculator, if we put this number on our calculator, it's going to be giving us 25 minus 1.9. It's going to be giving us 23.1 meters. So we just found out that our displacement here is 23.1 meters. That is our displacement. So we just found this displacement. So we are looking, just remember, we are looking for time. So in order to arrive here, we have to go through the process in order to reach time. So this, I think this is the only way in order to reach here in time. So we just found the distance from here. So therefore we can find the time from here. Find the time from here. So how can we find time? So remember, we know the velocity, final initial velocity, which is 12. So let us look back on our formulas. So back on our formulas. So on our formulas, we have three formulas. So the one that is fitable from the things that we have here, it is the third formula. It is the third formula, which that we have initial velocity. We have initial velocity. So we have displacement. We have displacement from here until here. We don't care about final velocity. It's not going to help for nothing because there's no final velocity. Even if we try to find final velocity, it won't work like that. So it is important to use this formula to be correct, sure, so that we shall not get lost. So we're going to be using this formula in order to find the time. So remember, this is not exactly the time that we need. I'm just calculating the time because it will be in handy on the next calculation that I'm going to be writing here. So it's going to be a change in displacement, because what we found is displacement is not high, it's not distance. So it's equals to initial velocity change in time plus 1/2 a change in time squared. So displacement, we just found out that is 3.1 meters. Okay, let us go to initial velocity. The initial velocity here is 12. So change in time. So remember, let us choose the direction. Even here, we have to choose the direction. Let us choose the direction. So from here, I'm gonna be choosing downwards as what is positive, because I don't want this A to be positive. So yeah, I'm gonna be choosing downwards as positive. So it's gonna be negative. So plus 1/2. Acceleration is gonna be 9.8. Change in time squared. Okay. So so gonna be 223.1 is equals to negative 12 change in time plus 1/2. No, let me just put this one on the computer. Sorry. So it's gonna be 1/2, which is gonna be giving us 1.8. It's gonna be giving us 4.9 change in time squared. So if you can see, our statement is easy to solve here. So we're gonna be taking this number to the other side in order to solve in the parallel way expansion. So we're gonna be saying that 4.9. I'm just putting things on my order. I'm just putting things in order so that I shall not get confused. That's why I'm taking this one. I'm gonna saying that change in time squared minus 12 change in time. So so this one is going to change direction. It's going to be negative 23.1. Now it's a trinomial. See? So we're going to put, I'm going to be using what is called so we're going to use this 12 yeah, plus 20 squared and minus 4 and then 4.9 negative 23.9, so 4.9 2.9. So we just found out. Let me just double check my calculation, because we can't just say it is true what I found. So because I can make mistake. So you have to be careful, guys, on your calculator, because sometimes you will think that the calculator is telling you the right answer. You have to double check again in order to confirm your right answer. So it's very important to double check your answer. So, okay. So our change in time squared is going to be given as 2.25. Let me just not round now. Very important not round. The middle number is rounded in the end. So I don't think it's very important to write the negative answer, because we're not looking for the negative one. Rather, we are looking for the time of positive, because time will never be negative. So let us just let's just get rid of the square root by square root both sides. It's gonna be square root and 2.2515 square root, and I cancel this square root and this squared, and change in time is gonna be equals to 2.2515. So they're giving us 1.5. Here the answer is the answer is 1.5 seconds. So guys, remember, this is not the time that we're looking for. The time that we're looking for is from the door, the top of the door, and to the down here from the door. That is the time that we're looking for. And so this time now we are not looking for it. We are just calculating this time in order to find the time from here. So we just found out the time here, right? We just found out the time. So remember, let us find out the time from the start until to the end. From the start until to the end. The whole time from the whole building. The time of the whole building. So we want it, but it's not what we are looking for. It will be handy. So so the formula, we're gonna use the same formula that we used in this time. So we're gonna be saying changing height now, and initial velocity change in time plus 1/2 a change in time squared. So we know the total height of the building, which is 25, is equals to final initial velocity is 12, right? It's 12. So I'm gonna be using I'm gonna be saying that upwards, downwards is positive, so it's gonna be negative. So change in time plus 1/2 acceleration is 9.8 change in time squared. So if we take this number from the other side, it's gonna be negative 12 change in time plus 1/2 9.8 change in time squared minus 25, because we just take the number this number from the other side because I change the sign. So I'm going to be putting these numbers in order. So it's going to be equals to, if you put this one on the calculator, it's going to be giving us 4.9 change in times squared. So I'm going to be putting this one because I'm putting things in order. So minus 12 change in time. So I'm going to be putting this one from here, it's going to be minus 25. So if we put these things on a calculator in our that formula of finding the x, forgot it. So it happens. I know you remember. I know you guys will know it, but I forgot. Remember later. So it's going to be negative 12 and 12 squared minus 4, 4.9 minus 25, right? It's going to be giving us 4.9. So if you can see, guys, the answer that we found here for positive time is given as 3.79. Yeah, 3.79 seconds. They're giving us this time. So this is not our final answer. Like I said, this is not our final answer that we are looking for. Henceforth, it is the answer which is going to help us to find the time, the actual time that we are looking for. How you guys understand that? So guys, sorry, I make a mistake on this one. Just make a mistake. Just find out that how come I found a 1.5. Just make a mistake. So just confirm it right now. Because confirm it because now this is not the right answer. This is not the right answer. So the right answer is 3.72 seconds. This is the right answer. Just found out that I just make mistake while calculating and forgot to put the brackets and the number. That's why it's giving us 1.5. So it's not a problem. You see how it is? You have to confirm it. You just don't need to rush so much with another question without double checking your answer. It's very, very important to double check your answer so that it should give you the right answer. When I'm writing it on, I know the answer. I know how to calculate minus signs. I always get my my calculation wrong. I forgot to put sign. Therefore, I learned that it's very important to be looking and double check your answer. If I forgot one sign, it's going to be wrong. So let us move to the another. Let us move find the time because we just found out the time from here, the total building from the top until the end. We found out it is 3 change in time. It's going to be 3.7 no, it's not 7.1. What is wrong with me today? 8. Remember, guys, the meaning of the so God is square. That's what God square. Make the square equal 5. So, even guys, I'm doing that. That's okay. So, I'm gonna be square root of 9 square. So, instead changing time, the actual total number for this one is going to be 3.79, which is actually giving us 1.9, 5. square. I forgot to put a square. Forgot to put a square. So I just found out that our answer here is 1.923 seconds. 1.123 because I just put a square to the side. So 1.123 is our seconds. And also here, just found out that it's 1.5 seconds. So I just hope this does not confuse you. So we have the total distance, the whole distance. We found out that it's 1.95 seconds. So the one that we are the displacement, one that is 1.93 seconds. That is the time that we found out. So we are looking for the time of the door. We're looking for this time of the door. So in order to find that time of the door, you have to do what? You have to say change in time one. Change in time one plus change in time two is equals to change in time total. So we found that our change in time one is the displacement that we found out is 1.93 seconds. Okay, so this one for the door we don't know. So for the total we do know is this one, 1.95 seconds. So if we take this to the other side, it's going to be 10 inside sign. Change in time seconds squared is equals to 1.95 minus that one, 1.93. Okay, change in time seconds. Okay. So if we put that number on our calculator, say 195 minus 1 comma 93, which is giving us 0.02 seconds. What a wonderful time. So our total, our time, the door is 0.02 seconds. Yo, guys, this is not, it's not supposed to be 4 months. This is supposed to be maybe 6 or something months. Yo, this is long, guys. This is long. It's very long. I'm telling you. I can a student think like in order this question need to be going through this one. But I understand you guys. I understand you why you just thought the question is with another question. I understand you. You're afraid of this. Even myself I'm getting confused. So but I understand you guys. Why you sometimes you dodge question and go to another question. Okay, let us move. So guys, let us move on in 3.3. So guys, let us move on in 3.3. So it says, draw a velocity versus time graph from the motion of the ball from the moment that the ball is thrown upwards until it strikes the ground. So use the ground as the zero reference. The ground as zero reference. Okay. So they said, clearly indicate the following on your graph. They're giving us the followings which we can write on our graph. So guys, many lot of students here, as far as I know, they just dodge graph and go to the question because they don't know so much about graph, and it's very little bit challenging for many lot of students. So guys, it is not good. It's not good to dodge graph and move to another maybe questions because you don't understand graph. It is maybe if you don't understand graph, just draw any graph that you know. It is possible that you might get it right. They might give you the mark of maybe writing writing the graph. So they just give us the following. So they said the velocity with which the ball was thrown downwards. So guys, if we can see on our graph,
they just giving us the velocity, which is 12 meters per second, and it is what they're looking for. So they just giving us the velocity. They're giving us the velocity. So the third, it says the time taken by the ball to reach its maximum height. So at maximum height, we just calculated and we found that our time is 1.22 seconds. All right. So and they just say in the third, the velocity with which the ball strikes the ground. So guys, we also calculated the final velocity, which is 2518 meters per second. So unfortunately, they didn't ask us to find a time, that we wasted our whole minutes and hour calculating the time. We are saved, because if they given us that one, it will be a problem for most students, and you can't dodge it. So our velocity, it is initial velocity, it is 12 meters per second as we've been given, and the time that we calculated, we found out it is 1.22 seconds. So the final velocity that we calculated, it is 25.8 minutes per second. So guys, let me show you some graph which you can draw. Many lot of students, they just do not know the velocity versus time graph. They just do not know. So I can help you know them. So so the graph that we're gonna be using, there's one graph but different. Like I said, if you can do anything in physics, in this kind of calculation, you have to choose direction. So also in graph, we have to also choose direction. So I'm gonna be saying upwards as positive. So upwards as positive, the graph of upwards as positive have to be like this. So don't forget to write velocity from here, and the timeline, it will be like this. This is the time, seconds, where the time lies, where the velocity lies. So we said upwards is positive because we just chose upwards as positive. So it's gonna be, the line is gonna be going down here. This is how we draw the graph of time versus velocity, as upwards is positive because of your choosing of your direction. So yes, time. So when you choose downwards as positive, so your graph will be like this. Will be like this. It's when you choose down it's positive. It's when you choose down it's positive. So I choose upwards as positive because it's helpful. I have initial velocity, it won't confuse me. But if you like, you can choose downwards as positive if you are sure you won't be confused on or substituting what you have been given. So I'm gonna be putting 12 minutes per second. This is the initial velocity. Final velocity, it's 25.18 seconds. Is 1.22 seconds. Here our graph, the graph is ended. So the graph is done, guys. 1 mark for initial velocity, and the other 1 mark for time, and other mark for final velocity. It gives us 3 marks. So we are done. So a lot of people, they will run away and go to another question because they're afraid. They think that graph, you have to maybe draw a lot of things, and guys, no, be patient and think and write and read your statement carefully and know what they need, so you will succeed on drawing your graph. So guys, thank you for watching the video. Great tough learners, I hope this will be helpful and be useful for your trial examination. I don't know if you've written the physical examination yet, but if you haven't written your physical examination of trial, it will be useful on the
December time or November examination. So guys, do not dodge a question and go to another question. Just a little bit, try a little bit. Just try and read your statement maybe twice or third times and read again with more understanding. So you will master it. So God, we're gonna be doing some of the things in the next videos which is challenging to you guys. I commend you can speak your challenging in the section comment. You can speak your problem and I can immediately prepare and give it to you and show you how it's done. So thank you for your time. Thank you for watching the video, and don't forget to do the following: subscribe and share the video for those who want to pass, and for your friends, and for those who are struggling to solve this kind of questions of projectile. So thank you and see you next time.